Welcome to Slooh, where educators bring live astronomy into their classrooms to inspire and engage their students in the study of space, astronomy, and earth science. Students and members use Slooh's live telescopes in the Canary Islands, Chile, and our Australian observatories to capture images of celestial objects they use in our unique curriculum-aligned Quest learning activities. But launching this fall, they'll also be able to peer back at Earth using orbiting satellites and our Earth science learning activities to study our home planet and expand the depth of their learning in geology, geography, environmental science, and space situational awareness. But let's get on with today's exciting event. I'm Paul Cox, and together with our expert guest, we're going to watch and learn about one of the most spectacular celestial events, a ring of fire solar eclipse. Now, you're seeing a black screen here, but you can just about make out there's a golden orb in there. Now we've got some, we're going to talk about where this is visible from. There's very, very limited visibility of this particular eclipse. And our partners are down in Chile, and the forecast is for light clouds. So we are going to see the sun come and go over the next hour and a half. But there it is. And hopefully they're going to adjust that telescope now that it's come out from behind the clouds, and keep your eyes open for the first little, there it is. Well done. As if on cue. Look at that. That is the beginning of the eclipse. Can you see that little nibble taken out of the sun? And that's the moon starting to pass in front of the sun. How exciting is that? We got some great images coming up. We got so much to talk about tonight. But don't forget, Slooh members and students can snap images from this live feed tonight. Just go to the Star Party page, select the tab marked Puerto Rio Tranquilo, and capture images by pressing the camera button, just like members do every night when they control the telescopes to capture the moon, planets, stars, star clusters, galaxies, and nebulae, and there's probably loads more as well. Now, you'll be able to use your images in our special Quest learning activity that we'll show you a bit later with one of my guests. Just like all of our quests, you'll learn more about the event and create a terrific infographic poster to showcase your images. And we saw some brilliant student posters created from our Harvest Supermoon Eclipse a couple of weeks ago. You can also create, of course, a time-lapse animation. Oh, we've got a second feed. Look at that. Oh, that's pretty cool, isn't it? I kind of quite like the bit of cloud going over, as long as it doesn't get too dense. It kind of adds to the atmosphere a little bit. But anyway, you'll also be able to create a time-lapse animation of the eclipse using our special Quest animation tool. So before we invite our first guest to join us to explain the basics of solar eclipses, let's take a look at the timings and what we're going to see. Now, as you can see, the partial phase of the eclipse has already started, but the big moment is in 1 hour and 20 minutes when the ring of fire appears. And we're going to explain all this a bit later on. We'll enjoy 3.5 minutes of what is called annularity before it returns to a partial solar eclipse. And that ends in around 3.25 hours, but we'll be on air until the end of the Ring of Fire. Now, we're going to be hosting up until the end of Ring of Fire, but then we're keeping the feed live so that you can carry on collecting images for the entire eclipse. We're going to explain all of that and everything else you need to know about solar eclipses during the Star Party. That's what we're going to see. But what are we going to learn about and discuss with our special guest? Well, we're going back to basics with a Solar Eclipse 101 with Slooh's Director of Curriculum, Dr. John Beauvert. John will also show us that special Eclipse Quest learning activity. And if we have time later, which I think we will, maybe we'll even show you how to create an eclipse animation. We've got a live interview from down in the south of Chile, where the annular eclipse is visible, with Professor Thomas Puja of the Institute of Astrophysics of the Catholic University in Chile. Now, Slooh's Chile telescopes are located at the university's observatory site, so they're a partner for way more than this event is. Now, Thomas and his team have traveled down from Santiago to the south of Chile, where they're providing our live eclipse feed, the feeds that you're seeing now through the clouds. Come on, everybody blow hard and get rid of those clouds, please. Um, Apparently it's pretty cold down there as well today. So have a thought for all of our event partners and the team that have gone down there with Thomas. We have got archaeoastronomer and educator Milton Villarreal. He's going to be joining us to share how um, South American ancient civilizations reacted to solar eclipses and the wonderful stories that they created in their attempt to understand these awe-inspiring and frankly what must have been a little bit frightening, these celestial events. What would you do if you didn't understand what was going on and suddenly the sun gets eaten up by the moon? Pretty scary, but those stories are absolutely fabulous. So make sure that you watch those. Don't forget, Slooh members can join us in Zoom to ask questions throughout the event. So just stick something in chat and we'll answer those as we can. So we've got plenty to look forward to. Let's get started and welcome my first guest, Dr. John Bovair, Slooh's Director of Curriculum. Hello, John, welcome.
Hi, Paul, and hi, Slooh members. I hope we're excited for this eclipse.
It's going to be a good one, isn't it?
It is. It's really funny. I always look forward to there's a little game that you can play with solar eclipses and who can see the first bite. And
Yeah.
I guess you and the Star Party itself are the winners today. This is
Exactly. And I do wonder actually whether they saw that first bite because it happened when there was a little bit of cloud there. So come on, we can just about see that faint kind of purplish globe there. We'll explain some of the feeds a little bit later, but keep your eyes peeled on those. So some of the images that you do capture may be black because you're actually capturing the clouds. But anyway, John, students and members use our online robotic telescopes to capture images of that myriad of celestial objects I mentioned. And they use those images in our Quest learning activities. Now, before we do our Eclipse 101, because we've got plenty of time, I love an Eclipse show because we always have plenty of time to discuss all of this stuff. Can you tell us a little bit more about Slooh Quest learning activities?
Absolutely. So our learning activities, they're called quests, and they're fun activities that surround students capturing different celestial objects and learning about them during these learning activities. So students are using their own images that they capture with our telescopes to learn all about different aspects of the night sky and adjacent topics like science, social studies, and more. We have professional grade telescopes in both hemispheres now. Well, we've had in both hemispheres, but we've recently opened up the new Australian observatory. So students have
Mm,
24/7 coverage to work on quests using any part of the sky, which is really awesome.
it is. And members have been raving about the new Australian telescope. I always, when I'm doing an educator webinar or talking to students, especially some of the elementary kids, but all the way up to college because we do the whole gamut. But some of our telescopes, including the Australian telescope, is so big, a lot of those students could actually fit inside it. John, what do you think of this live view that we're getting from Chile? We'll talk about it later, but this is our partners down at the Institute of Astrophysics in the Santiago Catholic University. What do you reckon of that? What can we see there, John? Because we can see some clouds, but is there something bad on the telescope? Because I can see some spots on the sun, can't I?
Yep, that's right. Yeah, those spots aren't on the telescope. Those spots are actually on the sun itself. And the sun goes through this 11-year cycle of being super active to not being very active. And we're in one of those really active phases right now. And so it's really awesome to see some sunspots on the disk of the sun. So what I like to do when I see sunspots during eclipses is I kind of use those as little pointers to remind me or tell me like how far has the moon actually come. So once it starts eclipsing some of those sunspots, it ends up being fun. These are
Wow,
some great feeds.
that's a cracking image, isn't it? So that little nibble, John, that's the moon passing in front of the sun. And we're going to explain that in our Eclipse 101. We were talking about Quest learning activities, the things that students use on Slooh. Are there any quests that are about this Ring of Fire eclipse?
There's a special moments quest called the Ring of Fire Solar Eclipse 2024 that's going to cover a lot of the same information that we're learning here today, but you'll be able to use the images that you snapped from our awesome feed partners today to make a quest poster showcasing all of the images that you captured. You can actually put up to 41 images on these posters. And just to give you a sneak peek of what some of those posters look like, this is one from our lunar phases quest. And so all of these images of the moon lunar phases are images that students capture themselves and they make this poster out of their images. And
Oh, cool.
what's really neat about solar eclipses is you can actually take your solar eclipse once annularity happens, you can take that image and you can put that into your lunar phases quest poster, and that way you'll actually capture the new moon phase. So that would be pretty awesome. Um,
Um,
but to give you a sneak peek, this is two of our eclipse posters that students on Slooh have made using images from the last two eclipse shows that we have. And so you can see that you can use these 41
wow.
slots to make a time lapse of the event, or be a little creative and crop them in a way to make this like really cool shape on your poster. So you are able to put on your creative hat and make something fun out of these images that you're going to be capturing today.
It is, and they're unique to every student, so you can have some artistic license in there as well. So that's great, John. So remind us how students and members can capture their images for the quest at the moment.
Absolutely. So when you're on the feed page, it looks like this, and you can see us here right now. But
So I
there's this.
can't see what you're sharing, John.
Uh-oh. Okay, let me be a little technical. So I hope that we can see this now. So this is the Star Party page. And as you mentioned,
I still can't see that, John.
um, what can you see? Uh,
I'm still seeing the main image feed. Maybe the studio can tell us if anything's going on. Oh, there you go. There you go, John. So we can see you now.
Yeah.
awesome,
So
great.
go ahead and try sharing for it now.
I think that we can see it. So this is the Star Party page, and there's this little button up here. It says Puerto Rio, Tranquilo, Chile. And this is when we click that, boom, now we can see the feed. And I've already been snapping a bunch of images, but just like if you were on any of the live telescopes, you just need to click on this little camera icon and boom, it will save an image of the eclipse. And so these images that you snap this way, you'll be able to use in the special quest. Now, you may want to know exactly where the quest is. So let me just briefly
Oh
show
yeah.
you where you go for that. So on the dashboard, there's a quest button at the top toolbar here. Once you get there, you'll want to click on all quests. And there's this really awesome search bar now where you can search for different things. So if you search for Eclipse and press enter, you'll see that, oh, it brought up our moments quest from the Harvest Supermoon eclipse. It brings up Mystery of the Changing Moon because we
No, that's
talk
a good one.
about eclipses in there. But here's the Ring of Fire Solar Eclipse 2024 quest. And when you click on that, it'll bring you to the quest overview page. Looks like I haven't started it yet. So once you hit start, you'll be able to get into the quest. And the quest, like I said, it teaches you all about the Ring of Fire solar eclipses, which are also called annular eclipses. And in the next step, you'll be able to put in your quest images. And the step after that, you'll be able to actually design your own poster, just like what I showed before.
That's going
So
to be very cool. So they are having a few issues down there because this is in such a remote place. So the live feed is coming and going a little bit at the moment, but we'll keep an eye on that. So bear with us. Yeah, we've got plenty of time. The moment is that 3.5 minutes I was telling you all about. That's going to be the really, really critical period for us. But so, John, have you got anything more to tell us about quest learning activities in this particular quest before we do a bit of a solar eclipse 101?
No, I think we can head right into the solar eclipse 101. Just want to keep on beating the drum though. When you're watching the live feeds, click on this camera icon button when the feed changes to get all of those images so you can make a Kraken poster at the end.
Yeah, I'm so looking forward to this. And of course, we're going to mention this later, but we're just launching the Gravity Awards, which reward students for their work using Slooh's telescopes and Quest learning activities. And I bet you we get some entries for that, John, because all students have to do to enter the Gravity Awards is to share their Quest posters or animations. And in fact, we've already got a couple of entrants who were on our Harvest Supermoon Eclipse Star Party because we had Mariana give a wonderful presentation. And also we had Matthew interviewing you for his media course. And those both earned them because it's a contribution to the community. That earned them a place in the Gravity Awards. That was quite cool. But anyway, let's go back
That is
then
cool.
to Solar Eclipses 101. First of all, John, there's a very obvious question. What is an eclipse?
So an eclipse is when one celestial body or spacecraft passes in front of another celestial body. So something is passing into the shadow cast by another body. And we can see that this is happening right here, that the moon is just starting to cover the sun. And so this word eclipse actually is derived from a Greek noun that means darkening of a heavenly body, which is kind of neat, actually, because that's what we're going to see from the sun. Here's kind of a diagram, a top-down diagram of the event that we're experiencing today. So the moon is just has like the shadow of the moon is on the surface, and in fact actually the anti-umbra is on the surface, but we'll get more into that in a little bit.
So looking at that diagram, John, the moon seems to be casting a shadow on the Earth's surface. Is that right?
Yeah, that's spot on, and pun is definitely intended for the event today. So our planet is passing through the moon's shadow, and this is what a solar eclipse is. Now, this diagram, it shows three parts of the eclipse. It shows an umbra, an anti-umbra, and a penumbra. I always have a hard time with that one.
I know.
Now,
Say
when
that five
solar,
times fast, John. Antumbra, yeah, you soon
okay,
trip up. It's not just you, don't worry.
okay, well, good, thankfully. So when solar eclipses occur, the moon shadow races across the Earth's surface. And when it's a ring of fire, like today, it's the anti-umbra that's racing across the surface. And for this one in particular today, it's actually pretty interesting. If I go, this is the eclipse path
John,
for the,
we've lost your screen share then.
uh-oh. All right, let's see. We see it now?
That's it. It's back.
Perfect. So this is the eclipse path for today's solar eclipse. And you could see that most of the eclipse today is going to be spending time in the Pacific Ocean. So it's going to be kind of difficult for folks to be able to
Mm.
see this eclipse. But we have these amazing streaming partners that actually went down to the southern tip of South America, where the eclipse is going to be passing over Chile and Argentina. And actually, fun fact, it is going to hit Easter Island a few hours before it hits the mainland of Chile, which I thought was
Yeah.
kind of interesting. But
What are the odds of that? Of this tiny island, in the Pacific, just happening to be in what we call the path of annularity in that little in between those red lines. It's quite surprising. And I can't remember seeing an eclipse. I guess one of the Antarctic eclipses where the path of totality or annularity actually crosses such um, really unpopulated areas. I mean, there are literally just a few towns within the path on the Chile side. There's a couple more on the coast of Argentina, but very few people are going to be able to witness this live. We have still got the live feed, so we could pop back to that at some point. Just take a look in between John's descriptions. There it is. God, yes. So it's
about
just,
that, oh, we can see it right there.
yeah. Yeah. Oh, that's worth a snap, John. Yeah, absolutely. That's worth a snap. So,
Definitely.
so John, there's
Yeah.
something specific, isn't there, that you love about you know eclipses because it gives us this unique opportunity, doesn't it, to see a particular phase of the moon that we can't see at any other time.
Yeah, that's right. The new moon phases is the only time to look and see a new moon phase is during a solar eclipse. And so it's quite awesome to be able to see that phase. And like I mentioned a little bit ago, make sure to capture that phase so you can add it to your lunar phases poster and actually get all 8 images using Slooh, which is going to be
Yeah.
pretty awesome.
Yeah, it's a
And
great thing to do. But of course, we only ever see it in silhouette as a new moon. And so
that's
often,
true.
we refer to a new moon as being, the moon when it comes out from behind the sun. So the first time we kind of see it at dusk, but that's actually a crescent moon by then. The new moon is a moment in time when it's aligned with the sun. And I'm sure you've got some other diagrams that you can show us here. But you mentioned that new moon phase. How often does solar eclipses occur? And shouldn't we see them every month since we've got a new moon every month?
You would think that we would get them every month. If I just go back to this lunar phases diagram again, this is the new moon, and it looks like it's in the same configuration
Yeah.
as it is today, right in between the sun and the earth. And new moon is defined being when the moon and the sun share the same right ascension. And so what ends up happening is the moon oftentimes either goes above or below the sun. And so this is a
Ah,
diagram that shows this. So the moon's orbital plane is tilted 5 degrees with respect to our plane orbiting around the sun. And so the ramifications of that is most of the time in a new moon phase, the shadow is either going to be below the earth or above the earth. But like we're in today, everything is lining up perfectly to where we can see an eclipse. And there's a special name for this. When 3 bodies line up together, astronomers call that a syzygy. So it's another one to say 3 times fast.
I love that word. It's a bit like Betelgeuse, isn't it? Say it three times fast. What happens when you say syzygy, syzygy, syzygy? um,
Great.
so we can see in that image, John, it looks like the new moon phase is when the moon is directly between the sun and earth. So you know, that's a great explanation. And so often, I see on my sky chart, when I'm tracking it around new moon, and you see it, there's the sun there, and you've either got the moon below it or the moon above it. So we can see that, very easily. So they are still struggling with their feeds a bit, down in southern Chile. I mean, one of the problems you get is, internet services are not terrific anyway, but this tends to happen with eclipses. So many people go to that small area that all of the communication systems, including mobiles, first thing to go down, but internet services as well just get utterly saturated, which is the worst possible thing for streams. But I know they're trying to switch between different ones. So, John,
Right.
I love that solar eclipse is the only time that we see that new moon. Other than the Moments quest, which I hope members have started that already because it's actually one of my favorite quests. I love all the lunar and solar quests. Are there any other quests they could use these eclipse images for?
Yes, other than the lunar phases quest, there's the Mystery of the Changing Moon quest, which students can use their solar eclipse image to add in for a new moon. And we also have for our middle school students a Phases of the Moon quest, where students can do the same thing, add their solar eclipse images as a new moon. Um, to definitely check those out. And you can find those even just by typing Eclipse in on the quest page, and it'll query those quests for you to see.
John, with the number of solar eclipses that we see every year, why are they so challenging to see?
Yeah, and we only see about 2 to 4, sometimes 5 solar eclipses each year. And total solar eclipses, which is even another class of solar eclipses we
Yeah.
haven't even talked about yet, those happen about once every 18 months. So the reason why they're so difficult to see, and I think the best thing to do is see the map of today's
Yeah.
eclipse. You pretty much have to be within the path of annularity in order to see the eclipse itself. So if you were on the mainland of South America, then you can only be in this small little area. And
How wide
luckily,
is the path, John?
it's at greatest eclipse, which is in the middle of the Pacific Ocean. So this would be the biggest that the shadow would be. It's only 266 kilometers or 165 miles wide. It's a pretty small area to be
Wow.
in. And I think you mentioned at the top of the hour that it's only going to have a period of annularity for only a few minutes. So that's
Yeah.
quite a small target at a specific time to see annularity.
Yeah. And the
So again,
closest you are. Sorry, John, carry on.
oh, I'm just going to say, and again, this is why we have to be very thankful for our streaming partners that
Hmm.
manage to get down to those areas to even let us see that. And that's one of the most awesome things about Slooh is I can be all the way up here on this part of the world where I'm not even going to see the penumbral shadow or at all, but yet I get to experience this eclipse here on Slooh.
Exactly. So, John, keep on that diagram for a second, because if you're in that path between the two red lines, then you see annularity. On a total solar eclipse, you'd see totality, which is just a league above every other type of eclipse. But you've got all of those other lines there as well. If you were in those zones, what would you see?
So you would actually see something that's the most maximum thing you would see is the moon partially covering the sun. And
Right.
on this map, there are these little numbers, 0.80, zero point 0.6, zero point 0.4. That's telling you the percentage that the moon is going to cover the solar disk. So if you were say on this red or this blue line here, then you'd only see the moon covering 40% of the sun. So the closer you get to the path of annularity, the more the moon is going to cover the sun.
Okay, John, we've got some time because we've got 5 minutes before Professor Puja joins us. Um, Different types of eclipses. We've talked about annularity. What's annularity about? Why aren't we going to see totality today?
It's a really good question, and it's, a lot of times when folks hear annularity, they think of the word annual, and these aren't eclipses that are happening once every year. Annular actually comes from the Latin word annulus, which means little ring, and so that's what we're going to see during annularity is a little ring of the sun, hence the ring of fire. And you may be wondering why isn't the moon completely covering the sun? And that's what's called a total solar eclipse, when the moon completely covers the sun. And it goes back again to how the moon is orbiting around the Earth. Now, anything that orbits around any other object is orbiting on a shape that's called an ellipse or an oval. Things don't orbit around other things in perfect circles. And so that means that during different parts, ooh, that's really awesome. I'm gonna make sure to snap that. That means that during different parts of where the moon is in its orbit, it's going to be either closer to the Earth or a bit further away from the Earth. And that affects how big the moon is in the sky. When the moon's closer to us, the moon appears bigger. And so if an eclipse happens when the moon is closer to us, that's called perigee, it will completely cover the sun's disk, and we'll actually be able to see the solar corona and a bunch of other really beautiful effects. However, when the moon isn't very close to us, it's a little bit further away from us, it's not going to be able to cover the entirety of the solar disk, and then we would have one of these annular eclipses. And so because the moon needs to be so close to us, that's why these ones are very rare, about once every 18 months. And that's actually an average rate. The next time that we're going to be having another total solar eclipse is in February 2026, and that's longer than 18 months from the last one that we had last April. Ooh, another awesome
That's
shot
another
coming in
great
on the sheet.
one. That's a
Wow.
good one. John, is the fact that we've got an annular eclipse today, when the moon is further away from us and its apparent size looks smaller, is that linked in any way to our star party 2 weeks ago, where we were looking at the supermoon, which is a super full moon? Is it linked in any way to that?
Absolutely, it absolutely is. Now, I'm gonna make sure to snap this other new shot that just came in, so that I can quickly go back to this image here. So when the tilting of the moon's orbit, once it gets aligned enough to have a solar eclipse or a lunar eclipse that we had last a couple weeks ago, there's not going to be enough time for the moon's orbit to incline enough away to where we're not going to have another eclipse a couple weeks later. So it's like you could think of as the moon orbits that plane kind of shifts a little bit. And so once we have one of the eclipses, either a solar or a lunar eclipse, we'll end up having another one a couple weeks later. So it's really fascinating. They're really linked to each other. And it's just the moon on its merry way going around the Earth.
Absolutely. John, excuse me if I get a little bit distracted. So I'm actually having to run some feed stuff on the side here. But, once again, we've got some time before Professor Puja joins us from Chile. I'm not sure whether his bandwidth is going to be up to it. But so let's talk about different types of eclipses. So we've mentioned a total solar eclipse. Today's one is officially called an annular eclipse, but a lot of people call them a ring of fire eclipse. But then we got these eclipses of the moon. So oh, look, do excuse me, John. I'm going to talk directly to Thomas. Hello, Thomas. Can you hear me?
Hey guys. Yes, I can hear you. Can you hear me?
Yes, we can. How are you? How cold is it? And what's the weather like?
The weather is like this. I don't know if you can see me.
Yeah, it's looking pretty cool. We've been getting some terrific views. Thank you so much for providing us these feeds today. So how many of you are there in your team from the Catholic University?
So at the moment, I think we are about like a dozen people here. So from the university, we have people here from the local community, basically, that organized this. From the firefighters, we're actually in the firefighter house transmitting here. This is our setup, our rigs. So everything that you see here maintained here by Simon.
Hi, Simon. Thank you very much for all of your hard work. So remind us exactly where you are, Thomas.
So we are in Puerto Rio Tranquilo, it's called. So that's in the south of Chile. It's the region Aysén. So it's like a state. It's far south, minus 46 latitude. So pretty chilly and windy down here, as you can probably see from the weather here behind you. Yeah.
This is exactly why we wanted to have an interview with you, so that we could get this eyewitness report, because the feeds are terrific, but it's just always wonderful to see the group of people there. Now, last time you joined us on an eclipse show, I think you were halfway up a volcano with that. And you had a bunch of students with you. Have you got students there with you this time?
Yeah, so Simon is actually a veteran student, right? He's now an observer at the telescope in Chile.
I can't share much with you because I have an interview as well.
That's right. So we are busy. We are multitasking like crazy here. So Simon he has been, I think, starting from the 2019 eclipse on our team, and the 2020, right, when we had this volcano cloud out disaster practically, right? We were really beautifully set up, and then at the last moment the clouds came in and completely clouded us during totality. But today it looks like we're gonna have a fantastic view on the annularity. As you can see, the clouds are moving in and out, but it's I think we're gonna see.
We're crossing fingers, and I did say actually right at the beginning of our star party, we got loads of students watching us tonight. I know a load of new schools and colleges have joined us tonight. I actually quite like seeing a little bit of cloud over an eclipse, because it gives that dynamism to the view, and it gives a depth, I think, to the view as well, doesn't it?
Yeah, totally. Like even looking through the camera feed live, you see the three-dimensionality, so you get a sense of like how how flimsy the atmosphere actually is, how how close it is, right? And then what you see in the background, this spectacle
Yeah.
of this marvelous dance of celestial
Now,
objects. It's
you're
amazing.
you're mid to late afternoon there. I think the sun's only going to be about 10 degrees above the horizon at the end
Exactly.
of the partial phase. What kind of horizon have you got there? And do you think you're going to be able to carry on the feed until the end?
I think we can, yeah. So we are pretty well set up. I think the sun. I mean, there is this ridge that you can see over there.
Okay.
I think it's going to be beautifully, set against this cloudy, wonderfully.
Oh, Thomas looks like he's cut out there a bit. Are you there, Thomas? Can you hear us? One of my next questions to Professor Puja was going to be one of the challenges with going to remote regions to cover eclipses. I've been lucky enough to go to Iceland and the middle of Africa, is internet. Because it gets absolutely saturated. You see what they're doing. They've got several feeds coming through, so they're streaming those live videos up. Thomas is obviously using, some bandwidth for his call. You saw Simon, his colleague, he's going to do another call. And then, of course, you've got everybody else there who are snapping images like crazy, probably sharing them on social and stuff like that. But one of the things I've always done on any eclipse expedition that I've done for Slooh, gosh, I'm a lucky boy, aren't I? I've probably got the best job in the world, is protect the stream. That has to, so normally it's video off for any calls, any interviews that you're doing or anything like that, because it's the feed that's important. And look at this. This is actually looking brilliant. Thomas, you're back. Hello.
I'm back. Yes.
I
Sorry.
I was just saying my next question to you was going to be about some of the challenges of going to these remote places and the internet connectivity. Have you been having issues with that today?
Precisely, that's the problem, as you experience right now. So we are really we're fighting, multiple connections. So we have a fiber optic signal here, but it's dropping in and out. We have also a backup of Starlink, but this is also dropping in and out. So we're trying to hop between the connections, and sometimes the feed just stops. But we are actively taking data and collecting data and streaming out. So let's
Well,
hope some of the data gets to you.
You're doing extremely well. And, I was just saying, I've been in the middle of Africa trying to do this over old-fashioned satellite comms, pre-Starlink days, and aligning, antennae and stuff like this in dust storms in the middle of Africa. So I feel for you greatly. And it's why I, and certainly all of Slooh members and students who are watching our coverage tonight, so greatly appreciate this. I mean, you've taken the whole team.
Sure.
How far away is it from Santiago? I mean, it's a couple of hundred miles.
No. I think it's like several thousand miles. I think we are pretty. I don't want to. I actually don't have the exact number, but I bet it's over 1,000 miles. So.
And you're traveling back to Santiago tomorrow, so you'll be having an eclipse party tonight, no doubt.
Yeah, absolutely. We're having here already many people congregating, coming in, many families, many kids showing up. There's a little bit of let me show you a little bit of
that would be
sit down
cool.
here, right? So you can see people are sitting down. There is cake and some pastries and
Brilliant.
people having a good time. More and more people are coming in, so the show
But
is starting.
I see you very sensibly roped off all of the equipment area. Now, Thomas, we've got loads of students watching our coverage today. Has Thomas gone again? He has. So students, hold on a sec, because listen to this next. Thomas, I've got a final question for you. We've got loads of students watching today.
Yes.
What advice, as a professor of astrophysics, would you give to them if they want to pursue a career in astronomy or astrophysics or the burgeoning space industry? Where should they start? What should they focus on when they're in school?
What you should focus on is your passion. Okay, do what fulfills you always in life. Follow your heart. do what interests you, and only this will make you excellent in any domain. Follow your passion.
Thank you. That great words. And I know you followed yours because you're an absolute eclipse chaser. Thank you so much for taking the time to join us with an eyewitness report. It's always marvelous to see where people are coming from. And thank you so much for providing the feeds today. Thomas, take
My
care and
pleasure.
send our best regards and thanks to the rest of the team.
Thank you. Pleasure working with you, Paul. Thanks to everyone. Thanks to the team.
Take
Okay,
care, Thomas.
we're gonna feed you. Yeah, bye.
Wow, that's always wonderful to see Professor Thomas Puja of the Institute of Astrophysics at the Catholic University in Chile. And just as a reminder, that is where their observatory site is, where Slooh's Chile observatory is based. We've got a massive 18-foot dome down there with 3 telescopes in it. 2 are always working. The other one we use for special events. But there you can see they're having a wonderful time. I was quite pleased actually to see how little cloud coverage they had. Now, before I invite our next guest on, I'd like to invite Dr. John Bovair back because he needs to remind me where we were getting to while I try and set up the image feed again. John, we were talking about different types of eclipses, weren't we?
Yes, we were talking about annular eclipses and solar eclipses and partial eclipses. And these images that we're getting from the feeds are so amazing. And a lot of times so this is a good example of when you're not in the perfectly path of annularity, you might only see what looks like this. And this is just the moon just partially covering the sun here. But later on, by a little bit after the turn of the hour, or I think it was turn of the hour plus 20 minutes, the moon will be covering the entirety of the moon will be covering the sun's disk. And so that's how we're going to see this beautiful little ring of the sun, the ring of the sun's photosphere. And that's the ring of fire. And all this is happening, and this is actually a very cool perspective to start thinking about the three-dimensional element of these solar eclipses, where the sun is way far away from us, but the moon is much closer, and it's just now starting to pass in front of the sun. Now, if the moon were a bit closer to us, then the moon would be bigger, and so it would then be able to completely cover the sun, and that would be a total solar eclipse. Now, what's kind of interesting is the Earth's orbit around the sun is also an ellipse or an oval. And so sometimes the sun will be a little bit bigger or a little bit smaller too. And so sometimes you can have eclipses where the sun is small because of where we're at in our orbit, and that makes it a little bit easier for total solar eclipses to happen, and vice versa. So it's really, really exciting the different kinds of eclipses that you can see
John,
potentially.
this is an absolutely remarkable cosmic coincidence, isn't it? That the apparent sizes of our moon and our local star, the sun, are almost identical. If you were on Mars and you saw Phobos and Deimos, they'd just be little spots and they'd be transiting across the sun like we see a Mercury transit or a Venus transit. But this
Mhm.
is a remarkable coincidence. I know you love math. Is there some math there involved in this cosmic coincidence?
Yeah, there definitely is. And it is totally a cosmic coincidence, and nothing really more than that, because the way that we understand how the moon formed, the moon in the very early solar system, there were other smaller minor planets in the inner solar system. One of them was named Theia. Well, is named Theia. But this little body was hanging out at one of the Lagrangian points in the Earth's orbit. And this is kind of like a gravitational eddy where um, you can have something kind of moving in concert with the Earth. And we actually see a lot of asteroids near Jupiter around Jupiter's Lagrangian points. Long story short, Theia got a little bit too much mass and was unstable in its orbit, and it actually collided with the early Earth. And in this collision, the formation of the moon happened. The Earth had a ring around it like Saturn for a little bit, but eventually it all coalesced into the moon. What's really fascinating though is the moon was much, much closer to us when it first formed. And the astronauts in the Apollo program, um, three of the Apollo missions, they left behind these instruments called a lunar range retro reflector, which is
Yeah.
basically a fancy word for a mirror. And they have it perfectly pointed towards the Earth. And so what they're able to do, and they actually do this in Apache Point, New Mexico, they shoot a laser from the Earth to the moon to reflect off of these special mirrors, and the laser bounces back to Earth, and we can calculate the round trip travel time for the laser pulse going there and back. And it turns out that the moon is moving away from us about an inch and a half a year.
Wow.
And so the ramifications of that, if you kind of, you know, turn to press the fast forward button, that means that we're slowly losing the moon. And so as the moon is getting further and further away from us, that means the size of the moon is going to get smaller and smaller and smaller. And so you could then ask the question, well, is the moon ever going to be so small that we'll never have a total solar
Yeah.
eclipse? Because we need to have the moon being kind of large to cover the entirety of the solar
Knowing
disk.
knowing you, John, I bet you've done the math on this.
I did. I did do a quick calculation on this, and I'm trying to remember the exact number. I think it was about like something ridiculous, like 100,000 years from now, or something like that. I'll have to look that up between next segments
Okay.
to refresh myself with that number. Um, but
But in cosmic
it's
terms,
basically
100,000 years really isn't that long at all. I was expecting you to say millions of years time. So what you're saying is that you will go and check this, but people, or whatever we are, AI, in 100,000 years time will not be able to witness a total solar eclipse from Earth's surface.
That's right. That's right. So,
Wow.
as many times as you can catch one of these total solar eclipses, definitely would be a good idea to do it.
Absolutely. So, John, just remind us what we're seeing here. I know there's only a couple of objects there, but just remind viewers if they've joined late what we're watching.
So we're watching right now an annular solar eclipse, also called a ring of fire solar eclipse. And what's happening is the moon is passing directly in between the sun and the earth. Another way you could think of it is the earth is passing through the shadow cast by the moon. And because the moon is a little bit further away than normal, well, it's a little bit further away from us. It's a little bit smaller, so it's only going to partially cover the entirety of the sun's disk. But our feeds are in the perfect position to where we're going to see an annularity.
Yeah.
So the moon is going to pass completely onto the solar disk, and that's special. That doesn't happen all the time when you're looking at these eclipses. But when that happens, we have a moment called annularity, where we'll see the outskirts, the outer limb of the sun with this moon, our moon, plopped right in the center of it.
Now,
And
there's an interesting point there, John, because you said that the path of annularity, when you see the Ring of Fire eclipse, is 165 miles wide or something like that. Now, our feed partners at the Catholic University are actually on the edge of that. Now, if you are in the center of that path of annularity, then what you would see is a perfectly concentric circle, ring of fire, all the way around. In other words, at maximum annularity, it's going to be an even amount of sun. But I want
Mhm.
viewers and students to keep watch, because during our annularity, because they're right at the edge of that path, we will see a ring of fire, but it won't be concentric. It won't be even all around the moon. So keep your eyes open for that, because I was looking where they are, John, and they really are right on the edge of the path of annularity. So that's going to be an interesting one to see how offset it is, isn't it?
Oh yeah, that's going to be really awesome to see. I
Yeah.
can't wait for that.
So, John, go back to basics because I know we've got elementary students, we've got college students here as well. We've got some great new colleges who have joined us. We were joined by some Purdue SMAP outreach activity students a couple of weeks ago during our Harvest Supermoon Eclipse show. If there are any students out there who want to join us on one of our live star parties to give a presentation or maybe just talk about some of the stuff they've been doing at Slooh, email me, paul@slooh.com. But go right back to basics, John. We're seeing a crescent sun there. The yellow thing is the sun, and the black thing is the moon passing in front of it. But you also pointed out some solar features that we can see as well, didn't you?
Yes, yes, I did. And when you look at the beautiful yellow partial sun, it's so weird to say partial sun, but you it's what it is in this
Yeah,
context.
yeah.
You can see that the moon is just about to hit these little black specks that seem to be on the telescope, but they're not on the telescope. Those are actually sunspots on the in the photosphere of the sun, which is basically the surface of the sun. And these are places on the sun where there's intense magnetic field lines either emerging or coming back down into them. And so it makes them a little bit cooler, less the temperature is a little bit lower for these than the surrounding area. So they look a little bit dark, but they're actually quite bright still, if we could somehow get rid of the rest of the yellow of the sun. But you can see that there's two kind of groups of sunspots that the moon is just about to start engulfing. And right on
Yeah.
the upper right of the sun, there's another little cluster
Oh,
of
yes, I can see.
sunspots there too. And so if you were watching from the beginning of the show to now, you would have actually seen more sunspots. But as the moon is starting to eclipse the sun, it's starting to eclipse all of those solar features too. But it's really fun.
John, we're watching a live telescope view of the sun today. It's got special filters on it. This happens, as you were telling us, a solar eclipse probably twice a year, something like that on average. But students using Slooh's online telescopes in the cosmic classroom, they get to see the sun every weekday, don't they? Tell us about how they're doing that and the kind of learning activities that they can do with this very special telescope, which is actually one of my favorite Slooh telescopes, I have to say.
Yes, this one is called an H alpha telescope. It's our solar telescope that's at our flagship observatory on Tenerife Island of Canary Islands, at the Astrophysics of the Canary Islands location. And every weekday, like you said, continued watching of the sun, and it's in this special view called H alpha. And H alpha is basically the brightest color that hydrogen, the most abundant element in the universe, emits. And the sun is mostly made of hydrogen. And so in those feeds, we're able to see these beautiful wisps and things called prominences, which are like torrents of solar material coming out, and filaments, which are those torrents kind of in front of the solar disk. And we could see more active regions and a lot of activity that's going on in the sun's
Yeah.
chromosphere, which is the region right above the photosphere. We're looking at the photosphere here, but our solar telescope sees just above that. And it gives you such an impressive view of what's going on in the sun. You can see different plumes that are flying off of the sun. And what's really awesome is students take these images and animate them, and you can see some things just floating off and moving and seeing how dynamic the sun is. Which brings me to some of the solar quests that we have at Slooh.
Hmm.
Do we have quests for high school students, colleges, middle school, and even for elementary school students to use the our solar telescope, Slooh Solar Telescope, to capture images of the sun and learn more about them, learn why we see what we see. And there's one in particular that I really like called Our Closest Star, where students take their images from Slooh's telescopes and then they use Earth's to measure the lengths of different
Yeah.
features on it. And it really gives you an immediate feeling for just the immensity of this
Yeah.
star that we have in the center of our solar system.
Yeah, it gives a sense of scale and perspective, which is good. Now, John, you're going to join us a little bit later, and we've got some open discussion topics. I think having talked about the solar telescope, maybe you could line up while I talk to our next guest, some of the observations that students have shared. And to remind new viewers what an observation is, it's an image or a quest poster that a student has created and they share with the rest of the community. They earn gravity points for doing that. Gravity points is Slooh's kind of currency for reward, a reward for contribution to the community. And we've just launched the Gravity Awards. And keep an eye open because next week there's going to be a new video out showcasing some of the latest work that students have done. So, John, we should take a look at that a little bit later. I also want to talk, do remind me later, I'd like to talk about the difference between an annular eclipse and a total solar eclipse. And we'll do that after annularity. And there's a very good reason why I want to do it after annularity. But John, thank you so much. I know that you're now going to leave us and you're going to be snapping images like mad, aren't you, for your own quest poster? I know you.
I have been, and I'm excited to with what I've been catching so far. So make sure that students listening capture your images too, because not only will you be able to use them in the special quest for today, the special Ring of Fire quest, but also animate them in the Slooh animation
Yeah.
quest. I did find the result, and I was off for when the last potential
Oh,
total solar eclipse was. I was off by 1,000. It was around um 500 million years from now, half a billion
half a
years we
billion years
have
time.
to enjoy total solar eclipses before they're probably gone.
Okay.
Well, they will
Well,
be gone. We'd actually have to enjoy them from a spacecraft at that point.
well, with every total solar eclipse at my age, I always feel fortunate that I can just see the next one, frankly, let alone think about half a billion years' time. But John, fascinating talking to you. We'll talk a little bit later because you're going to join me for the moment of annularity and we can have a good chat then. And just to remind everybody, that moment of annularity, the ring of fire, occurs from our particular location because it's different where you are. From our particular location at 22 minutes and 32 seconds past the hour. So 25 minutes, something like that. So, John, we will see you later. Thank you.
Sounds great. Thank you.
Now, one aspect of astronomy, we're going to move away from the science now, because one of the aspects of astronomy that we love here at Slooh is that it's not just about science. Many of our quests look at astronomy through the lens of art, literature, history, and culture. And that's what we're going to talk about now with our next guest. He's a longtime Slooh member, an educator and lecturer. And his native cultural studies led him to specialize in archaeoastronomy in South and Central America. I would like to introduce Milton Villarreal. Hello, Milton. How are you?
Hi, Paul, and hi, everybody. It's always a pleasure to connect and talk about the cosmos, bring those stories from the past, hoping to influence our present and future.
Now, just to explain before we start talking about the eclipse, what's archaeoastronomy for any students out there who like the sound of that? What is it?
Okay, ancient cultures left buildings mainly and some pieces of art that archaeology keeps and preserves, but through the study of those samples, we discovered that our people were busy looking at the skies and why not even predicting what was going to happen. So archaeoastronomy derives from those two sciences that join, whatever they left for us to study and how we can, in a way, show the world what they thought about the cosmos.
So we're not on total opposite sides of the world, but you grew up in South America. I grew up here in Southern England. We've talked before. You know that 7 miles in that direction for me is the monument called Stonehenge, a Neolithic ring of stones, which we now understand through archaeoastronomy studies, um, they were monitoring the movement of the sun and the moon and possibly the stars, mainly for their calendar, knowing when to plant crops and basically tell the time of the year. But let's go closer to your home. What did the Maya think solar eclipses were as a real basic? Because I can imagine that they were seeing this kind of thing in total fear. And if not total fear, then just very, very difficult to comprehend what was going on. So what did the Maya think about this?
All right. One of the things that fascinates me is how most cultures in the world have that in common. I'm pretty sure the Druids or the
Mm,
builders of Stonehenge also thought about the skies in very similar ways as the people in Central and South America. So, for example, the Maya had an ability to calendarize everything. If studios can show the Maya calendar for a little second, it's that gearbox kind of array that they invented to keep track of this. So they use the calendar for what you said, laying their crops or picking up their food, but they also use the calendar to observe the skies and to do their best to predict some of these events. And I find it fascinating that by hundreds of years of observation, they were able
mm,
to get very interesting conclusions about the cosmic dance of the objects in the sky.
exactly. Now, is this the calendar which conspiracy theorists and others misinterpreted very badly as forecasting the end of the world back in the year 2000 or something?
Yes, it's the base of that calendar. The Maya, for example, studied the calendar or the year in that way, and the Aztec were the ones who took all that knowledge and tried to apply it in their own way. Now, we discovered the calendar stone of the Aztec, and we tried our best to, do the same prediction. And
Right.
I'm glad to say that we were very off. We're still here.
I know.
Uh,
I can remember
2012 is past.
yeah, oh, it was 2012. So I can remember, Milton, we actually did a live star party, a broadcast, which was titled The End of the World Live. And we basically waited for the clock to tick over and said, well, yep, we're still here. It's a bit like fighting the flat earthers and stuff like that. So, when I was looking at the live image view there, we're talking about these ancient civilizations. They didn't have telescopes and things like this. And quite often, even if you were looking at this without, filters, which you must not do, it would be, excuse me, too bright to see. But of course, they would have seen these kind of eclipses in great clarity if clouds were passing because they'd see it behind. This also casts these crescent shadows down on the ground, which is one of the most wonderful parts, I think, about most eclipses during the partial phases, that most people are looking at it with their eclipse glasses on and stuff like that. But there's loads of lovely phenomena that actually happen behind you in the shadow of trees and your own shadow, and the whole lighting kind of changes as well, doesn't it?
Exactly. Let's remember that the Maya lived near a forest, right? So, or within the forest. So for
Ah,
them, it was a show, the only show they could, every time there was an eclipse, they could see thousands of eclipses around them by looking on the floor and observing how the little, points of light reflected the
yeah.
eclipse there. So yeah,
So,
there's a lot of that going on there.
so we're 15 minutes away from annularity, the ring of fire. What did they think annular eclipses were? What was going on in their
Oh,
heads? How did they explain it?
the Maya, for example, and the studio can help me with this. They thought that there was an eye in the sky. Okay, there was definitely what we call the eye of the sky looking down on us, and this is particularly true for the annular eclipse. On screen, you see one manuscript that Maya left. That we only have very few of those. because of the material they were written on, and the time that we have to preserve them. But that's the symbol of an eclipse, for example, the one that has a dark side and a light side. They are trying to reflect how they saw the moment in which the sun was covered, and there was this moment of dark and light that you can actually see in the feed that we have right now. When the moon is passing across the orb of the sun.
I mean, it's beautiful art as well as a kind of scientific demonstration. I mean, they're recording what they're observing, and observation is the absolute foundation of science, especially a science like astronomy. But they're just beautiful. They're just beautiful pieces of artwork as well, aren't they?
Oh, they are. They are really. And I totally agree with you saying that they had a basis of scientific thought. It's not that they didn't know anything about it, but what I like is the moment in which they join both science and mythology, for example, to try to have a complete idea of everything around them. And in particular, right now, for example, you mentioned before, or Mr. John Bouvier mentioned that the path of annularity will take us through the island of Rapa Nui, or the Eastern Island. And for them, for example, this particular event was a moment to have a meeting. All the town would sit around, the fire, let's say, and that way they would imitate what was going on in the sky, and they would share stories. They would share mythology. It was a moment in which the whole town would gather around and renew their stories, their own culture. They would dance, they would tell stories, or perform some ways of art, and that's really an interesting way of linking the world that we live on with the upper world, which is common in all these ancient cultures too.
So they were basically having an eclipse party. But you were talking about storytelling there, and before the written word, that's how so much knowledge was handed down from one generation to another, because people can remember stories far better than they can remember facts. I mean, that's the storytelling tradition is among all the ancient cultures that we know about. And then when the written word does come, one of the first things they start doing is capturing those stories in the written word.
Exactly.
Yeah. But
I am an educator by profession, and one of the best ways you can teach anybody anything is by telling a story. I agree with you. That story will be a better mnemonic than numbers or tables or any statistics. They will remember the story.
And you've written some of our quests in that kind of way as well. Well, remind us what the main quest is that you wrote, Milton.
Okay, one of the main quests was the dark shadows of the Milky Way that is behind me right now. We have a privileged view of the Milky Way down in the southern hemisphere, and all those shadows that you see that we watch from here carry a meaning. And what I wanted to share with the rest of the world was exactly what those meanings were, which correspond to the year cycle of the Inca culture. So, for example, there was a shadow that represented the rainy season, for example, the frog. There is a shadow that represents the pickup season, and when you have to take care of the llama that you raise, right? And there is a season where you have to be careful of predator animals that will come and get um, your lamb or anything you were keeping there. And everything is crowned by the flight of the condor of the Andes, biggest bird they have.
Yeah.
All of those shadows have a little meaning, and I was really happy, not only writing it, but also researching on that.
It's
The
one of
other
it's one of
story,
yeah. It's one of the most popular cultural quests that we have. You'll be pleased to hear. So what
I
was the
am
other?
very glad to know that. Thank you. And it's something that started as only an idea, but now it's given me a lot of positive feedback because sometimes you're wondering if people out there would like to listen to these stories, but the feedback I receive is very positive and, of course, encouraging to continue telling stories like this.
Yeah. And it's always a
The other
pleasure.
one I'm very
Yeah.
proud of, which Slooh made possible, was the moment in which we participated in Observe the Moon Night, the one that just passed, let's say. Our
Yeah.
time came a couple of years ago, and Slooh asked me to tell the stories in my own language, in Spanish, because that was the interest of Observe the Moon Night, to share stories in different languages.
Mm.
And thanks to John Bouvier and you and everybody at the Slooh team, I was able to share 3 stories. I said, let them choose, right? And they loved all of them, and they were presented in 2 different presentations during that Observe the Moon Night week, let's say. According to Dr. Bouvier, it was a quest that wrote itself because we put all of them together. We gave it the Slooh format, and it was out there. It was even out there before the dark constellations of the Inca.
Yeah.
So you never know, right? So how things
Yeah.
proceed. And well, again, that's another one that has given me a lot of positive feedback because the way we look at the moon that's always been there is very different across cultures.
Yeah. It's a remarkable quest, and any students who are watching, I think we've got over 1,000 watching on the Star Party page. We've got quite a few in the Zoom webinar. I know some teachers join the Zoom webinar, and then for the Harvest Supermoon Eclipse, they put it on the big screen at the front of the classroom, and everybody's watching at the same time. So they're kind of having their own mini
Hi,
Star
everybody.
Party. So yeah, exactly.
Warmest
So
regards from South America.
we are going to be pulling on your Spanish skills even more, I hope, in the future, Milton, for maybe some student classes. But I got one last question for you when we're talking about the Maya. And what role did eclipses have in Maya cosmology?
Oh, for Maya, all the eclipse occasions were omens. Really, they were not good news.
Right.
Simply because their biggest god, the sun, let's say, was being blocked, right? In South America, I remember I mentioned that a jaguar was eating the
Mm,
sun, let's say. And in Mesoamerica, for the Maya, the Aztec, this basically was a moment in which, again, their energy, the source of energy, was being blocked, and they would believe that this was the end of the world for them, really.
mm,
So they were very glad to know that it was only a temporary thing, but their knowledge made it so that they had to try to foresee the next one, to
yeah.
predict the next one. That's why in the calendar slide I wrote the keepers of time, because they were people specialized on keeping time and keeping track of these happenings in the sky. That was their main task,
Yeah.
in that culture.
And it gave them a huge amount of power. Certainly the Druids and the people here in the UK, in China, in so many different cultures through the ages. Those people who could predict a celestial event like this, maybe it's a total lunar eclipse when the moon goes red. Imagine what the rest of the population, let alone their leaders, would think of them, that they were able to predict this happening when there are no watches. They can hardly know what day it is. let alone being able to predict. So there's a tremendous amount of power. There was a tremendous amount of secrecy as well around a lot of those people who could predict these things because it meant power and wealth for them.
I totally agree. That was one of the secrets of keeping power for dynasties and dynasties, you know. They really wanted to keep the secret, and little by little, you know, that secret is out. And something that I love about being connected through internet, through Slooh, is that we bring everybody together,
Yeah.
and we try to explain, you know, all this, you know, to all our community, which is really a different way of thinking. Everybody should know about this. Everybody should know why things happen if we
Yeah.
want to connect with our world. You know, a lot of people really don't understand why these things happen.
Yeah.
It's because they live, you know, in their cell phone screens without looking up, and that's what we are trying to do here. We encourage
It
everybody
is.
to look up, get inspired, and you know, find more wonderful things
Yeah.
on their telescopes, not on their cell phones.
Yeah, a bit of awe and wonder never hurt anybody. Milton, it is always an absolute pleasure to welcome you onto one of our star parties with unique perspective and knowledge. So thank you so much for joining us today. Enjoy the rest of the eclipse. It's looking pretty good, isn't it? That's a lovely crescent. So Milton, thank you very much indeed for joining us.
Thank you for having me, Paul, and thank you everybody and the rest of the world.
Thank you, Milton. Milton Villarreal, educator, archaeoastronomer, quest author extraordinaire. Always an absolute pleasure to hear about South American ancient culture and how they saw astronomy and these amazing events that we're witnessing today. Now, I would like to welcome back Dr. John Beauvert, Slooh's Director of Curriculum. Hello, John. How are you?
Hi, Paul. I'm doing well. Snapping more pictures and actually putting some into the Slooh's animation module, so animation quest.
Oh, are you? Are you? So, okay, so the timing said this annularity is going to be at 24 minutes past. So we've got some time, and I think what we should talk about, we deliberately didn't put this at the beginning, because we've seen the first phase, or we are seeing the first phase or stage of an eclipse, which is the partial phase. We're still in it. But John, can you take us back and go through the key stages of a ring of fire solar eclipse?
Definitely. There's 5 stages to an annular eclipse. 4 of them are called contacts. And so the first stage is when the partial eclipse begins. So this is right at the moment that the moon takes that first bite out of the sun. And so we got to first contact right when the show started. And we've been in the second stage, also known as second contact, since then. This is when the moon is moving further and further in front of the sun. Now, the moon isn't completely over the sun yet. We can see, you can actually, this is such a cool image because you can really start to see that now the sun's disk is on that bottom half of the moon.
Yeah, it's starting to envelop the moon now, isn't it? As
Yeah,
soon as
it
it goes
is.
past halfway and it's cradling the moon, it's absolutely stunning.
It's awesome. So once once the right and left parts of the sun's solar limb connect up with each other, and we have the entirety of the moon in front of the solar disk, that's when the maximum eclipse is. That is the time of annularity.
Okay.
And this is the beautiful ring of fire that we've been waiting for. And like you mentioned before, Paul, since the feeds aren't right in the center of the path of annularity. The moon isn't going to cover right in the smack dab in the center of the sun, but it's going to give a nice little thin ring in the bottom and a thicker one at the top. It's gonna look really cool.
It's
And it's
interesting
gonna
because at the moment it does kind of look as if it's going to cross symmetrically, but we know it's not, and I kind of, I love geometry and stuff like that. You love math, geometry for me, give me shapes that I can play with and hold and draw
Math
and
with
stuff.
shapes.
Yeah, I guess so. But this is, I mean, I also love the color gradient that we're seeing, on the sun. A lot of that is due to the filter and stuff like that, but it just adds another perspective to this. But it is really strange because this is a different kind of, we see a crescent moon, but it's a different kind of crescent, isn't it, John, that we're
That's
seeing here?
That's right. The crescent moon is light reflecting off of the moon and coming towards us. But this is a little different. This is the actual moon itself moving in front of eclipsing the sun. So it's in a totally different way. And that's actually a really good point about lunar eclipses, is that when a lunar eclipse happens, the moon isn't going through all of the lunar phases. It's the shadow of the Earth that's just passing in front of the moon, just like we have the moon itself passing in front of the sun here.
Yeah,
Um,
looking at the phases of the moon, um, and in fact, lunar eclipses. I haven't heard any flat Earth believers explain away how we can see those particular curves. But anyway, maybe that's one for, maybe we should do a debunking conspiracy star party at some point, John. So we have the
that'd be fun.
annular phase during this Ring of Fire eclipse. Then we've got a couple of other phases. It kind of just goes in reverse, doesn't it?
Yeah, it totally does. It's so the fourth stage or third contact is the end of the annularity. So we'll start to see some of the moon crossing over the sun's
Hey,
limb,
John,
which is,
just John, could you just hold on a sec? I'd
of
just like to
course.
ask the studio. I think if you can remove that from your screen, refresh that stream feed because you've got a lag on that, on the one that you've got up, because the one that I've got is a lot closer. Because I was starting to get worried about that timing, but actually, if you can refresh that and get it back on screen fairly quickly, because we said it's going to be 22 and 30, and here it comes. Come on,
It's
there you
really
go.
close. Woo, there it
Whoa,
is.
well done, studio. I'm glad I butted in there, John. What do you make of
Yeah, me
this?
too. This is amazing. So we're just about to get into the annular phase. Oh, it's getting even closer. Those two parts of the sun are just about to start touching, and you can
They
already
are.
see that it's not perfect. The moon isn't perfectly centered,
No.
just
Oh,
like we predicted.
look, there it
Oh,
goes.
this could be another game. Who can spot the
Wow,
eclipse? Oh, I think there it
exactly.
is.
Yeah, I think that's a definite. I've got it on my small screen next to me as well, so I'm going to make sure that everybody can get a snap of that. But as you say, John, we've got this offset moon because we're on the side of the path of annularity. If you wanted a perfectly even or alignment, you'd need to be on the central path of annularity. But my goodness, how weird is that when we see two objects which are so familiar in the night sky, just in a totally different way? So we are reaching roughly, just looking at my clock, this is about, it's coming up to maximum, another 30 seconds or something like that, is
Oh,
going to be
wow.
maximum annularity. What do you think make of this, John? It's absolutely astonishing, isn't it?
It's incredibly astonishing. Going back to the geometry of it, you can totally see how they're not right in line. The right side is a bit thicker than the left side.
Yeah,
Um, and gosh, I can almost see how the moon is just going to keep on cruising there and just never make it in the center. That is so cool. It's like every eclipse is so unique in some way. So make sure, please, students, to capture these images. These are going to be
exactly.
so awesome.
These are going to be good. And how lucky were we? Because the forecast for today in Chile, and don't forget the path of annularity, so it crosses a tiny amount of land. We've got Easter Island, a little slither of Chile, southern tip of Chile, a little slither of Argentina as well. They're sparsely populated areas, so not many people can get down there to have a look at this. And the weather at this time of year is traditionally quite bad. I think there was an 80% chance of cloud cover. We had some cloud
I
earlier,
mean,
but look at this. This is
yeah,
fabulous. So who's
it
going to be the
is.
first then, John? We're now watching for, what is it? Is it called third contact, this one?
Uh, yeah, we're now watching for third contact. Yes, the fourth stage. They kind of named the numbering's a little awkward, but
Yeah.
yeah, third contact is what we're looking for. So the top part, maybe the top, just like maybe 1 o'clock of the moon is probably, well, no, actually, I don't know, maybe like
I reckon
11
it's going to be
o'clock.
11 o'clock. Yeah.
Yeah, yeah,
So
that's gonna
it's
hit.
going up. Just look at where it's getting thinner, thinner, thinner. And the moment that you see a
Wow.
break in that ring of fire, that's the end of the annular ring of fire eclipse. Then it's a partial solar eclipse. So here it
Hmm.
goes. It's so close. But look at the disparity of, the size of the moon in comparison to the sun, and thinking that during a total solar eclipse, it's the same size or slightly larger. What do you reckon, John? It's going, isn't it?
It is.
Or
Oh,
is that it? Do you
is
reckon
that
that's
it?
no? I can still see a very. I'm going to make sure that we get a capture of that. That's it. I can
Oh,
see. I
there it
can now
is.
see a break. Yeah, definitely. So that's it. That's the end of annularity. And who knew? The timing said 2 seconds past 26 minutes past the hour, and that was virtually dot on. I mean, there are some time lags in the feed, but I actually I actually quite enjoy this particular phase, John. When it's nearly annular, there's something about this. There's a I don't know if you're a Harry Potter film fan, but I am. Um, love Harry Potter films, and there is Draco Malfoy and Harry Potter are having a dueling match on top of this huge dining table. Next time you watch that film, think of this image that we're seeing now, this very peculiar crescent sun and two circles overlapping each other, because the whole tablecloth in that scene going along the whole table is a whole set of diagrams like this. And I've always wondered, is it trying to depict an eclipse? Because it's a whole set of graduating crescents like this. But it's,
But that's fascinating. Yeah, I'll definitely keep an eye out for that next time I give that one a go through.
we've been so lucky with the weather, and it was great actually to have that live interview from Chile with Professor Thomas, and actually seeing um, their surroundings. And I was so pleased to see mainly blue sky. Given that during the feed, during the first half an hour, we had total blackout in some of these feeds. So, and bang,
Yeah,
there we are. It's another annular eclipse is over. So, but we're going to keep so John, we're going to carry on talking because we've got a couple more little things that we can talk about. I'd like to talk about. We'll also answer any questions. Oh, Hank's saying in chat, the horns of God. Yeah, they do look like horns, don't they? Isn't which was the Egyptian god? um, because there's a headpiece. Whenever you see them depicted, somebody in chat will tell us, but you see it depicted with that Ra. Hank is saying, and I'm sure it's
ah,
depicted
yes.
with that kind of horn-shaped crescent as a headdress or something like that. So, John,
It totally does. Yeah.
what did we say we were going to talk about? We were going to talk about the difference between total solar eclipses and annular solar eclipses. Now, the reason why I didn't want to talk about it before is because, in my opinion, a total solar eclipse literally totally eclipses an annular or partial eclipse. It is stratospherically beyond as a spectacle the annular eclipse that we just saw. And this alone, I absolutely adore an annular eclipse. I think what we just saw was absolutely beautiful. But John, tell us what's different about a total solar eclipse that makes the human reaction to it very different to the human reaction that the people down in Chile and Argentina and Easter Island with their eclipse glasses would have seen with this.
Yeah, there's two main things that I can really think about, and I've had the joy of being able to experience an annular eclipse in person, and I mean it gets a little bit darker out, and you can kind
Mm,
of feel a little bit of a temperature change, but you can still see that the sky is blue. But in a
yeah.
total solar eclipse, the moon is gonna cover the entirety of the sun's disk there. And so it's gonna get actually dark enough to be able to see the stars during the day, which is really fascinating. But even more than that, you'll be able to see the outer layer of the sun called the corona, which is always there. It's there right now, but the corona is very dim compared to the rest of the sun. And so we can't see it unless we blot out the solar disk somehow. And what better way to do that than using the moon? And so we can see these beautiful I almost want to say haunting, but it's really
Yeah, it is.
awe-inspiring to
Yeah.
see the corona itself. A beautiful way description that I've heard about this during the last total solar eclipse star party, which we were on location
Yeah.
to get that one, is that it almost looks kind of metallic in the sky,
Yeah.
and it's unlike anything that you've ever seen. And so, like you said, Paul, it eclipses all of the other solar eclipses.
Types of
Total,
eclipse.
yeah,
I love a total lunar eclipse as well. But one of
yeah,
the things you said there, John, is, about the impact that a total solar eclipse has on your local environment. It goes pitch black. You can see the brightest stars. You can see the planets on either side of the sun. Um, the feeling hits a lot of people at their very core. Whereas everybody who was watching this, even at maximum eclipse, maximum annularity, as you say, it was still daylight. And even during a total solar eclipse, it's not until that last little bit of the sun is obscured that bang, it feels like the lights have gone out. And anybody who's watched any of our total solar eclipse star parties and expeditions that I've been on, for well over a decade now, will know that this hard Englishman is brought to tears every single time I witness totality. It is literally the most awe-inspiring event I have ever seen, and I've been lucky enough to see several of them. Unfortunately, some of them facing a camera while the eclipse is happening behind me, which is a bit of a shame. But I have managed to get little glimpses, and I have to say, John, the one that we did in the USA earlier this year was one of the best. And actually, I saw that with my own eyes. The way we were set up to broadcast, I was able to see that far better than any of the others that I'd seen. And actually, Slooh's founder, Michael Palucci, came over to me after totality during a little break. I was talking to him, and I think it was during an interview that I was doing with him, actually. And I just welled up. It's just totally overwhelming for me, totality. And anybody who gets the opportunity to see a total solar eclipse, don't think that you can be a few miles outside of that path of totality, because it is just a totally different event. It really is. And I heard so many people over the years say, oh no, don't worry, we're going to be about 50 miles away or even 3 miles away, whatever. No, it is a totally different event. If you ever, students watching and everybody, if you ever get the opportunity to witness totality, make sure you are as close to the center line of the path of totality as possible, because the closer you are to the center, the longer totality lasts. John, I think you can remember, I think it was before you joined Slooh as director of curriculum, but I did one expedition to the middle of Africa, and totality for that lasted 13 seconds. We were very lucky earlier this year, weren't we? Because I think it was a minute and a half, maybe slightly longer.
Yeah, it was enough for people to have these reactions to it.
Yeah.
And I know that when I wasn't here for the African total solar eclipse, but I remember that you were even having to juggle getting the filters on and off and then back on to the telescope so that everybody could enjoy
Yeah.
it. And there's a lot of work that happens behind the scenes to get these to
Yeah,
see solar eclipses.
exactly. And we have to thank the whole Slooh team, because to get the feeds up, to get the quest, John, you did the quest, but we've got Gretchen in the studio as well. We've got our special guests on this. There's so many different parts of the machine that runs these and gets these online for us. So John, let me ask you a question then. When are we going to manage to get you on a Slooh eclipse expedition so you can see your first totality, in the flesh?
The next one that happens, if there's a seat for me, I'm there. I'm there. I
Well,
only have to say the word.
I tell you, I think that would be absolutely fabulous fun. You and I hosting from location to witness a total solar eclipse together, and maybe if you can, you can take over while I burst into tears like I normally do.
I was about to say we need to find a third person because I might be bursting in tears with you.
I got a sneaky suspicion you will. I mean, every total solar eclipse we've covered, we've had Dr. Kate Russo on, who's a psychologist, and she's also an eclipse chaser, and she has studied the impact of totality. She's written books on it, papers on it, studied the impact of totality on human beings and the way it makes them feel. And she's interviewed thousands of people now over the last 10, 20 years. And it's that they've actually brought it down to the psychological sense of awe. And I think one of their last scientific papers or books was using that word. And, awe is something that can actually be measured in brain waves. And during the eclipse earlier this year, they were trialing some headsets on a whole range of people. And it was actually reading the brain waves, and they were trying to spot a Project Or. Thank you very much. I've just been told in chat, Project Or, and they were trying to pinpoint the brain waves which were responsible for that overwhelming sense of awe. And we talked to Dr. Kate Russo, didn't we, John? And we were saying, well, does the explanation and understanding of this thing spoil it slightly? Personally, I don't think it does. But then we're a bit geeky and nerdy, aren't we? We kind of like the explanation. It doesn't spoil anything for us. It adds to the enjoyment.
Right, yeah, adds to the enjoyment, adds to just the special circumstance that we happen to find ourselves in. And that's incredibly fascinating to hear about Project Awe and that research. Definitely need to go check that out for myself.
Hey, John, before we wind up the hosted part of the show, don't forget we're keeping the feed live so you can carry on watching on the Star Party page and carry on, on that little button, picking images for your Quest posters. But John, before we wrap up the hosted part of the Star Party, is there anything that you wanted to share about the Quest or animation or anything you've been doing behind the scenes at all?
Yeah, I can show everybody where the animation quest is and give them just
That would
kind
be
of a
cool.
quick glimpse of what they'll need to do. So let me so here I'm sharing my screen here. And so I'm going to go, if you start back at the quest page, you're on the all quests and you have this little search bar here. If you search for animation, you'll end up seeing actually a number of our quests where students make time-lapse animations. These ones are for recreating the discovery of Pluto and learning all about Clyde Tombaugh. We even have some for animating lunar phases, but all the way at the bottom here, there's the Slooh animation quest. And in that quest, it's a very simple quest. It's only 2 steps. Make your time lapse and claim your badge. But it's one that once you're finished with and collected your first badge for making an animation, there'll be a button that says edit quest that pops up here that you'll be able to use and make more animations if you'd like. So on that step, there's 38 slots for you to put images in. And so I just threw maybe about like 15 images in while
Right.
we were enjoying the eclipse here. So it's not the entire eclipse. So you need to make that yourself to see the entirety of the eclipse. But all the way at the bottom, there's the spot where you can actually make your animation. And so
Okay.
here, all of the frames that I put in are actually here, and we can see the first frame, and you actually have to use these little arrow keys to move the eclipse images around to line up the sun. Now, this is actually a really awesome experience because the sun, as you can see, is still it's all the sun is the same shape, is the same size in all of the images. So it's really about a matter of making the sun line up with each other, which, come on, spinning circle, finish.
You shouldn't have loaded
Mm,
so many images, John.
I know I shouldn't have loaded so many images. I should have kept it exactly where it was. Um, there we go.
There you go.
Okay. Well, one of these frames are going to be a little off,
Yeah,
but you can
don't worry about
hit
that.
play here and we can see the eclipse happening. And so
Oh,
it's a
that's very
really
cool.
cool way to animate the images from the eclipse. So just imagine getting the whole thing going all the way across. Once you make that animation, you could share it as an observation and put some interesting info for it. So an observation is something where students have captured an image from the telescopes, they post it to the community, and they add some information about what it is they're seeing. And there's some really amazing animation or amazing observations out here. This one is one of my favorite from the
Yeah.
last solstice. And this student has marked up the image and they put how many miles this huge filament was. And I actually really love the solar image because the active regions made a little smiley face here on the sun.
I thought exactly that. That's the first thing I kind of saw in it. A kind of cat's face, maybe smiley cat's face. But they've
Yeah.
also added a little Earth to scale, um, a kind of icon on there as well, which gives us that sense of scale. So I love
Yeah,
that.
it's pretty crazy. And like I mentioned, you really can put animations as observations. So here's one that's I believe it's 40 some images, and this is
Wow.
coming right from Slooh's solar telescope, our H alpha telescope. And this is what students are doing every day is they're watching the sun be active and dynamic and continuously changing. And so these are some of the things that you can do with the solar telescope as well. So a little
Uh,
bit about observations there.
Hey, John, I've got a question for you. It's come from Hank. This is great. Do we have access to the animation tool without a specific quest? And that's exactly the quest that you just showed us, because you can load any images into the animation quest, can't you?
You can add any images from your photo roll. So anything that you've captured on Slooh. And I mean you anything you really want to animate, you can do that. And like I
Yeah.
said, once you collect your badge for the quest, you can return back to this overview page and there'll be an edit quest button. You click that button and it'll let you go back in and
Load
remove
more
your
images.
images and put in all of the images from today's
Yeah.
eclipse and do
Yeah.
the same thing,
So you
making
could even make
animation.
an actually an animated GIF of your favorite Slooh images, almost as a slideshow. It doesn't have to be of the same object, even, but animation, time lapse animation is blink comparing, is what astronomers often call it, and it's often used to track transitory phenomena. So it's trying to spot the difference between two things, and it's how Clyde Tombaugh discovered Pluto. It's how most near asteroids and asteroids have been discovered, by taking an image of a field of stars, taking another image at another time, and blink comparing them. You've got all of the stars staying exactly the same place and nothing changes. But if you see a little white dot or something else moving somewhere across it, you've probably made a discovery. So, John, what else have you got to show us here?
That's
That
that's
was
what I
it.
have. Yep.
Well, thank you very much for that. I am so looking forward to seeing students' posters. You've got another hour, students. The live feed is going to stay there. Actually, John, I wonder if you could just pull up the event page, just remind students who may have joined late, because they've still got a chance to capture some images, exactly where and how they can capture these special images from our feed down in Chile.
Yeah, definitely. So when you first get onto the Star Party page, it's going to look like this. You can see the Star Party happening live here if I were to press play. But right up here at the top where there's a number one, it says Puerto Rio Tranquilo, Chile. This is our live feed. So when you click on that, it'll bring you to this page here where we can see the live feeds, and right under the image you'll see the camera icon button, which is the same icon that appears on our telescope pages. And every time you click that camera button, you're capturing an image of what you see in the feeds. And this is actually the only way that you'll be able to capture
Yeah.
images to complete the Ring of Fire 2024 quest.
Actually, just remind, we've got some educators in. Can you remind them what a moment's quest is, John, and how long a period they have that they can actually do or assign a moment's quest to their students like this one?
Yeah, so a Moments Quest is a quest that's tied to a star party, and our star parties are surrounding special events like eclipses or comet passings, and with the images that students capture during the star party, during the time that the feeds are active, we've made quests for students to use those images to make posters or animations or learn more about the event that's happening. Now, the thing that you'll have to do though is your students will have to capture these images of these events while these feeds are open, because when the feeds are down, if your students haven't captured the images, then they won't have images to be able to put in the data collection modules.
Mm.
So make sure that your students are capturing images of the eclipse. Now, for the Moments quest itself, we typically keep those quests up for about 1 to 2 weeks. In this case, this one's going to be available for 2 weeks, but all your students need to do is start the quest. If your
Yeah.
student starts the quest, then they can take as long as they have, because you probably assigned it to them, to complete the quest. But if a student were to try starting the quest 3 weeks from now, they won't even find it on the platform. So it's important that if you want your students to do these quests, to assign it to them and make sure you tell them to at least start the quest so that they can finish it.
Hey, John, I'm about to talk about what's coming up. Can you show educators and students where they can see upcoming star parties? Because a lot of our star parties will have associated moments quests with them. So I wonder if you can just click on the little calendar icon up there, which should top right and give us a little list. So here we can see we've got a couple of star parties. We can watch that one live, but we've got a couple coming up. So we've got the Blaze Star blows its top, and then we've got Countdown to Europa Clipper. John, tell us about the Blaze Star quickly and what we're waiting for and why the date for this star party keeps changing. What's going on there?
Yeah, so in the Blaze Star, while it may seem like it's only a single star, the Blaze Star system are two stars that are orbiting around each other. There's a big giant star called a red giant and a small dense star called a white dwarf. And the gravity from the white dwarf is accreting or pulling in the material from that red dwarf and causing it to orbit around the white dwarf. And we're waiting for some of that material to fall onto the white dwarf surface, because that material, which is mostly hydrogen, when it hits the surface, all that hydrogen is going to explode like a massive hydrogen bomb in the cosmos. And we're going to be able to see the system brighten up by about 1,000 times. You'll actually be able to see the Blaze Star with your naked eye when this occurs. And so we've been waiting for it to actually go off. It was predicted to go off maybe in September, but we're creeping into October. But
Yeah.
with these things, we've only seen the Blaze Star go erupt like this 2 other times, and so I think we can give ourselves a little bit of a break for not being quite bang on with the date.
Yeah.
It typically happens about once every 80 years. So once the Blaze Star goes off, we're going to have a star party to show the system. And there's actually currently a quest right now called the Blaze Star Quest, where you can learn all about the Blaze Star and the event, which is called a Nova event, and get yourself prepped for the star party. But and capture images of the Blaze Star before it goes off. But if you want to wait until the Blaze Star happens, you can do that too. The quest will still be there for you.
Yeah, it's going to be a good
But
one. I'm just hoping It's already too low now in the southern hemisphere, so we can no longer observe and capture the blaze star from the Chilean Australian observatories that finished last week. And unless it blows its top soon, it's going to be too low in the northern hemisphere as well. So we've got to cross fingers and hope this thing finally goes boom quite quickly.
That's right. Pretty much every night when I take my dog out before bed, I'm been watching the Corona Borealis, the constellation it's in,
Yeah.
is getting lower and lower and lower, and just like really hoping that we catch
No.
it. Yeah.
Oh. Hey, John, thank you so much for joining us tonight. It's always an absolute pleasure hearing your explanations, which if I can understand them, anybody can understand them. So thank you very much for all of that insight. And it's always marvelous actually just sharing one of these celestial events with you anyway. You know, we're colleagues, we work together every day, but somehow these events don't feel like work, do they?
No, no. I mean, we do all of a lot of prep work for these, so
Yeah,
now it's time to enjoy the ride.
this is the fun bit. So thank you, John, for
Mhm.
joining us. We'll see you again for the Blaze Star. So anyway,
Sounds great. Thank you, Paul, and thank you, Slooh members.
yeah, thank you. It is time to end the hosted part of the Star Party. I'd like to thank our special guest, Dr. John Beauvais, Professor Thomas Puja of the Institute of Astrophysics at the Catholic University in Chile, who is providing these terrific live feeds. And thanks to longtime member Milton Villarreal, archaeoastronomer and educator, for sharing those wonderful eclipse stories from ancient South American civilizations, where we're going to be trying to persuade Milton to conduct a few Slooh student star parties, a few student classes in Spanish, which will be quite good. We got loads coming up here at Slooh over the coming months. As you see, we've got the Blaze Star. Watch out for announcements on our new Earth Science program and the Gravity Awards that will showcase and reward students' work using Slooh's unique educational platform, as you've seen. We're also partnering with the Jet Propulsion Laboratory to provide live images of Jupiter and its moons for their pre-launch party of what's called the Europa Clipper mission on October 9th. We've got special guests from JPL who are going to share the story of that remarkable mission and tell students some of the amazing job opportunities that they've got open to them in the space industry and how to actually get there. But don't forget, you can carry on capturing images on the Star Party page. It's just going to be the main video of the feed. No music, no audio, nothing like that, but you can go over to the tab to capture your images of those live images coming in from Chile. But that's it for now. Until next time, clear skies, everyone.